This is arranged for the BHpO Computational Challenge 2023. We have completed all the tasks and created a GUI application that showcases all of our work. It's a fully functional application, doesn't require a compiler, with a very pretty icon. It can be used by anyone who has access to our application without needing to use any code. As you can see, we've got all the tasks here, so let's begin with task 1.
Using the libraries Matplotlib and NumPy, we dived deep into the heart of orbital mechanics, and we examined how the square of the orbital period relates to the cube of the orbital semi-major axis. Using the parameters of our solar system, we found that the relationship holds true, and it is pretty close to unity.
Task 2 now.
We used the data and we precisely computed and plotted the elliptical orbits of the 5 inner planets, Mercury, Venus, Earth, and Mars, and Jupiter. After we did that, we scaled up the canvas and we showcased orbits of the outer planets, Jupiter, Saturn, Uranus, and Neptune, and also Pluto.
The task 3 and 4 was to create animations. So firstly for task 3, we were able to create an animation where you can start the animation, you can stop it, you can resume, and then you can also reset the whole animation. We did this for the inner planets as well as the outer planets in 2D. As you can see, the animation's going really well. You can stop it, and then, like I said, you can resume. This is also the case for the 3D orbits, the 3D plots with fully functional animations. You can stop them, resume, and reset. It works for each one very nicely.
By continuing on to task 5, we delved into the relationship between orbital time and polar angle, and we employed Simpson's numeric integration method and deciphered how these two factors intertwine. We then developed a function to calculate orbit polar angle from orbit time, and we incorporated this function into our models. We compared the polar angle variations over time for Pluto with a circular motion. We also added a slider, which allows you to change the eccentricity.
Moving on to task 6, we had to create spirographs for different planets in our solar systems. We separated it into inner and outer planets. So we created this application. We can choose 2 different planets. You can choose the number of orbits, let's say 15, and you can, as you can see, you can plot it. It works for all the planets. So Venus, Mars, Venus, Mercury. It works for all of them. You can change the orbits how you want, and if you select the same planet, you get an error message. And it also works for the outer planets. We can pick 2, select the number of orbits, and you can plot them. It works very nicely, as you can see. So for task 7, as required, we plotted the paths of other celestial bodies in relation to a chosen planet. So you can choose a planet out of the inner planets, such as Mercury. Choose the number of years, for example 15. You can plot in 2D as well as in 3D. It works for all the bodies very nicely. It also works for the outer planets. Again, you can choose the number of years. You can also plot in 3D. Very nice. Thank you.